So this is your spherical mirror, concave spherical mirror, principal axis, pole of the mirror, and this is the center of curvature. And remember, the principal focus is a point which is lying on the principal axis, such that the rays, incident rays parallel to the principal axis, after reflection meet at that point. This was the principal focus. Now, what is this? This distance between P and C, pole and center of curvature, is called radius of curvature, and distance between focal length and the pole. So, the distance between principal focus and the pole is called the focal length. So, represented by F. The relation between these two is such that R is equal to twice F always, or F is equal to R divided by 2. So you need to remember this, that principal focus lies between at the midpoint of the center of curvature and the pole of the mirror. Always the distance of center of curvature from the pole is twice the distance of principal focus and the pole. So R is equal to 2F, or F is equal to R by 2. So this derivation, if you want, you can read, but otherwise it is not in your syllabus. You don't have to derive or prove this, just have to remember this. Okay. Now we come to the main point, how images are formed. Before we do that, let us understand that an image of an object is formed when two rays, at least two rays after reflection from the surface meet at one point. So image of a point is formed at any point only if two rays from that point on the object after reflection meet at any point or appear to be meeting at one point. So we need to consider different rays and their reflection and see whether these rays after reflection meet at a single point or not. So if they actually meet, we get a real image. If they don't actually meet, but seem to be meeting at any point or seem to be spreading from any point, then it becomes a virtual image. So representation of images formed by spherical mirror using ray diagram. So we are going to draw a ray diagram, and then we'll be able to represent the images formed by the spherical mirror. So to find the position and nature of an image of an object formed by the spherical mirror, we have to draw ray diagram. Okay. So when suppose we have a spherical mirror, this pole, center of curvature, principal focus, and suppose this is an object somewhere at position O. This is A and this is B. So what actually happens on every point on the object, from every point of the object, there are infinite rays that are emitting from that point in all directions. So हर एक point पे object के हर point से जो rays होती हैं वो हर direction में emit होती हैं. तो वो सब उनमें से कुछ rays, some of them, these rays are incident at the surface of the mirror. They get reflected and they move in any particular direction. If these reflected rays meet at any point, two or more than two rays meet at any point, that point becomes the image of this point from which the rays are being emitted. तो ऑब्जेक्ट के जिस पॉइंट से रेज एमिट होने के बाद, रिफ्लेक्शन होने के बाद किसी एक जगह पे जाके मिलती हैं या मिलती हुई नजर आती हैं, तो वो पॉइंट जो है वो इमेज बन जाती है ऑब्जेक्ट की. और इसके लिए वी कैन कंसीडर at least two rays we have to consider. If at least two rays meet at one point, then we say that that point becomes the image. So there are some convenient ways that we can consider for formation of images. So one is that if the incident ray is parallel to the principal axis, we'll consider a ray which is when the incident which is parallel to the principal axis. Incident ray of light parallel to the principal axis. So what I'm trying to say is, suppose I want to find out if this point is A at the tip of the arrow. I want to find out where will be the image of this point A formed after reflection from this by this spherical mirror. So what I'll do, because I know there are number of rays which are being emitted from this point, so I'll consider one ray which is parallel to the principal axis. So this is one of the rays which is being emitted from this point A, and this is parallel to principal axis. And the ray which is parallel to principal axis always after reflection passes from the principal focus. So you have to understand it. This is very convenient to draw and very convenient to understand also. So there are number of rays, but one ray we consider the reflection of one ray by the spherical mirror, which ray is parallel to the principal axis, and the ray parallel to principal axis passes from the principal focus. So this is in case of a concave mirror, not reflex mirror. So this is the case second mirror. Again, we have this center of curvature here, principal focus, and this point is pole. And suppose this is an object in front of the reflecting surface of the mirror. So this point is A, this point is B, and this position is O, object position. Now I want to find out where the image of point A will be found. I'll consider one ray which is parallel to the principal axis. So this is the principal axis, this is parallel. Now this ray will be reflected in this direction. So if you extend it backwards, you will find that this ray is being seems to be this ray seems to be coming from the point principal focus. So it seems to be originating from point A. So that means when in case of concave mirror, it actually passes from a principal focus. In case of convex mirror, it appears to be passing from the principal focus. So one thing is common about this: the ray after reflection actually passes from the principal focus, which is parallel to principal axis, or it appears to be passing from the principal focus. So one ray is this that we are going to consider while formation of images by the spherical mirrors. Now, why this ray is moving in this particular direction? You connect this point. Suppose this point is K, where the ray is incident, with this center of curvature. So when you connect this, the CK becomes normal to this point normal to the spherical mirror at point K. So this is the angle of incidence, but that is between incident ray and the normal, and this is the angle of reflection, that is between reflected ray and the normal. And the first rule, the first law of reflection says that angle of incidence is equal to angle of reflection, and that is why this ray which is parallel to principal axis always passes from the focus. Okay, and you know this distance, this point F lies at the midpoint of P and C, at the midpoint of radius of curvature. So this angle is equal to this angle. Similarly, here also the same rule. If you suppose this point is K, where the ray is incident, join K and C and extend. You will find that now K and C becomes, KC becomes the normal at point K. So this angle is angle of incidence and this is angle of reflection, and both are equal. So first law is being obeyed here, the first law of reflection, and that is why the ray is reflected in this particular direction. So this is one ray. The second ray we can consider for formation of images is the incident ray of light is passing through the principal focus of the spherical mirror. Incident ray passing through the focus or principal focus of the spherical mirror. Okay, second ray, that is incident, and it is passing from the principal focus. So I'll consider once again a concave surface. Whole center of curvature, and this is principal focus. Let us suppose this is an object A here, AB, at point O. So let us now, because the rays are going in all directions from A, let us consider a ray which is passing from the principal focus. So this is a ray we are trying to find in which direction it will be reflected. The ray which is passing from the principal focus, after reflection, always is reflected along the direction which is parallel to the principal axis. Okay, so the ray which is passing from the principal focus and is incident on the spherical mirror will always pass or will always be reflected along the direction of principal or parallel to the direction of principal focus. The same thing happens in case of a convex spherical mirror also. This is the principal axis, center of curvature, focus, P. Now a ray, now in this case the ray, because this is a mirror, cannot actually pass from F but appears to be passing from F. So the ray which appears to be passing from F, so this is the ray which is coming from any, will be incident at point and it will be reflected parallel to the principal axis, and it appears to be passing from focus, not actually passing from focus, but appears to be passing from the focus. So that ray will also be reflected parallel to the principal axis. So this is how a ray is reflected when it passes from the, when the incident wave passing from the principal focus. So these are two rays. We consider two more rays for image formation. Now another ray we can consider is the incident ray passing through the center of curvature of the spherical mirror. incident ray passing through the center of curvature of the spherical mirror. Once again, concave surface. Principal axis, pole, center of curvature and principal focus. Suppose this is the object at point O, A, B. We are considering a ray coming from A, but this ray is now passing through the center of curvature. Suppose the incident ray is passing through the center of curvature. So it will move in this direction from A to C and then forward. And it will meet the ray at point K. Now, if you remember the center point joining any point on the mirror, when it is joined with the center of curvature, then this line joining the center of curvature and the any point on the mirror acts as a normal at that point. Now this ray is incident normally at point K. So when it is incident normally, it will be reflected in the same direction along the same path. तो जिस रास्ते से आई थी उसी रास्ते से चली जाएगी. तो नॉर्मल के साथ इस रे का एंगल 0 बन रहा है क्योंकि नॉर्मल के अलॉन्ग है, तो वापस भी वही 0 एंगल बनाते हुए ये रिफ्लेक्ट हो जाएगी. And in case of convex mirror also, it will be reflected along the path along which it is incident at any point on the mirror. So here in this case, this is center of curvature, this is principal focus, this is pole. Suppose object is placed in front of the mirror A, B. Now a ray, because there is a mirror in between, cannot actually pass through C, but appears to be passing through C. It will move in the direction from A to C. So let us say this is a ray. So this ray will be incident at point K in this direction. It will be reflected back along same direction. But this ray is actually not passing through center of curvature, but it seems to be passing through the center of curvature. It is along the same direction as if it is passing through the center of curvature, and it will be reflected back along the same direction. One more ray that we consider for image formation is when the incident ray is traveling obliquely to the principal axis, that is, it is making some angle with the principal incident ray traveling oblique